Hello and welcome everyone. Thank you for joining us today for our webinar titled Predicting Customer Churn with Accurate and Explainable AI Models. My name is Patrick Moran. I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Karthik Guruswamy is a Senior Principal Solutions Architect at H2O.ai. And before I hand it over to Karthik, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the Questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. And without further ado, I'd like to hand it over to Karthik.
Thanks, Patrick. Hi, everyone. Good morning, good afternoon, good evening, and thanks for joining my webinar. So we're going to be talking about predicting churn with accurate and explainable models. That's our topic today. So I'm going to do some intro about myself and H2O, and then we'll talk about churn as a problem, right? So, and the various aspects that goes into building a churn model. And then we'll do a demo on some data using driverless AI, and then we'll go to the Q&A. So about me, I have a bachelor's in electronics and communication long time ago. I've been in this industry, both analytics and data science, with Astrodata and Teradata, and now at H2O. I'm also a blogger. I've written blogs on Forbes, LinkedIn, and Medium, and some of you might have been following that. And just something about me, I'm not a great golfer, but I'm trying, and I'm also a biker. I guess I need to put something there. So I'm not just a data scientist, but I'm also doing other stuff. And then let's talk about H2O. If you're not familiar with H2O, it's a startup founded in Silicon Valley in 2012. Raised a bunch of funding from, you can see the investors there. So H2O originally started with open source, but now working on, we've been also selling commercial software, and we have some really awesome customers. That's just a small customer list. We are based out of Mountain View, and then, we have about 240 people in the company, used by a lot of universities, and, you can see like more than 20,000 companies use open source H2O. And then we have regular meetups and webinars like this one. Okay, so our team is primarily a core of H2O is a team of Kaggle grandmasters, right? So we have some of the world-leading data scientists that are helping us to build products, and you can see they are spread all over the world. Some of the best in NLP, time series, so their expertise has gone into all the products. So when you actually use driverless AI or H2O products, you're actually be like a data scientist working, like a Kaggle grandmaster working on your site. Okay, so that's kind of a brief introduction of H2O. So let's go to the main topic of the webinar, right? Churn. All right. So what is churn? The simplest definition of churn is when people stop subscribing to your service. Right? If you have a business and you have a service and you have monthly or yearly subscriptions, then they stop subscribing to your service and then close their account, right? So that's churn. Typically, churn is measured by what is known as churn rate, and that's just a simple formula, and I'm sure there are a lot of other ways to calculate churn. But really, you're looking at, the number of customers on the beginning of the month, and then if you're measuring churn rate per quarter, you'll be looking at, maybe March 31st. Let's say you have 800 customers on January 1st when you started your 1,000, you have a churn rate of 20%, right? Now, that may or may not include the new customers that have signed up during that quarter, but overall you're looking at the decline in customers. So in order to understand churn, obviously, there's like so many different ways to look at it, and there's all these nuances around how you define it. But there are some basic differences. For example, what is churn versus cancellation, right? Churn is someone who leaves permanently, right? They probably went to another customer. A cancellation could be something temporary, so you can probably reverse it, right? So they probably canceled it for some trivial reason, and then it could be an involuntary cancellation, and then they come back, right? And then you also have a notion of revenue churn versus customer churn. Customer churn is when a customer leaves the business permanently as a customer. And then the revenue churn is like if you're on a premium tier and then they go back to like a free tier or something, right? So they're still with you, but they're just not paying you. So you have a revenue fall, right? Like you have a revenue churn. So those are some of the definitions. And the final one is a soft churn, right? This is something that's a lot of bank accounts. For example, you may have a lot of bank accounts. You may have one bank account where you have multiple credit cards. You may have another one that's probably paying your bills. And then, so basically, and you have another bank account, just lying around and not doing anything, right? You're still not made up your mind. So you don't have a whole lot of balance, and sometimes you move all the balances to one active account, and then you just leave it dormant. You can call it a soft churn, right? So there is some opportunity to, upsell something there, but really they're not making use of the account, right? So that's called a soft churn, or usually comes from like things like balance diminishment and dormant accounts. So obviously all of these are important, right? Regardless of whether it's a revenue churn or a soft churn, churn is churn, right? In the sense you have there is a real potential of loss of revenue, and then basically you want to reacquire the customer and start, have them start paying you again, right? So what are the different costs of churn? So folks on the webinar, you probably know this from your own experience, right? Typically poor onboarding. You sold someone a product and then you haven't trained them enough, maybe, or they are just there and there's lack of ongoing engagement, excitement, right? Typically this happens with mobile apps, right? So you get onto a mobile app and then you have a monthly premium and then you start paying, and then you don't get any notifications from the app and you just forgot about it. And then when the renewal comes up, you're like, hey, I'm not really using it. I just used it one time, and there isn't like nothing active going on in terms of, reach, or they're asking you to do something. So you kind of like lose interest and then you go away. It could be a poor product fit, right? So you thought you're getting something, but it's not really helping your outcome, right? And so that could be another way. And then poor product experience. So there's a lot of bugs to use, right? If you have a cell phone, then, if you have a poor cell signal reception, you're going to churn, right? And then, so you have an issue, and then sometimes you call the customer service, you're waiting for a long time, bad customer service. And sometimes your needs change. Sometimes you want it for a reason, and then your needs change. And then pricing and competition obviously are big factors. So there is competition that's offering something at a much lower price. So you decide to, switch your cell phone carrier or, whatever service that you subscribe to. And there are other ways to churn. It's like an involuntary churn, like your credit card expired and then you go away and you probably don't know this and they restart to you, right? And then, so there's so many different costs of churn. So some of them might be pretty obvious when you run a BI report or something and then something comes up on top. Sometimes the reasons could be complex. It could be sometimes more than one here, right? It could be a perfect storm that where you lose a customer. It's not just one thing. It's just like a couple of things that happens. So we really want to know this, and especially if you have 20 customers, you can probably talk to them. But what if you have 10,000 customers or 100,000 customers? Then you really need a way to build a model and then actually use it, and then smartly address the issues, right? Like you want to really proactively address the issues before the customer drops out, and that's exactly the sort of like the main theme of the webinar is to understand the cost of churn and build a model, understand the cost of churn, and then do something proactive, right? Just month over month, you're always having a list of people that might go away, and then you're just reaching out to them, intelligently, right? You're not going to go after, send emails to all the 100,000 customers you have, right? You probably want to pick the top 1,000 people who are most likely to churn, and then talk to them a little bit differently. For each one may have a different reason. And that way you're engaging them, and they know that you're engaging them, so you're going to keep the customers. Okay, so we already talked about this, right? So we want to find the causes of churn, and then the most important thing is sometimes it's good to know your customer is not satisfied or the price is too high, but you really want to know what's the right price, right? So there is a particular price after which certain customers leave, a bunch of customers, a significant people leave, right? So you really want to understand that. And price not just being one of the things, right? It's probably the quality of service and the amount they're willing to pay. And we really want to understand the inflex points of, anything that's numeric values that they hold with you. Like the price could be one, or it could be how long they are with you, right? So there's like all of these things you really want to understand numerically, right? Like what would be those inflex points or critical triggers after which a customer leaves, right? Or even stays. And then obviously we want to create, we talked about this, we want to create personalized marketing campaigns. Personalized is the key thing here. You want to have a very targeted campaign offers for the potential churners and not to all your customers, right? Because you don't want to offer discounts to all your customers because you really want to offer discounts to the one that matter, that you think are going to churn. And obviously the reason why we are so concerned about churn is the cost of new customer acquisition is probably 10 times more than 10 times than the cost of retention, right? If customers are happy, they're going to stay with you. Obviously, it takes a lot more dollars to acquire a new customer, and churn customers is probably impossible to reacquire again unless the competitors are really bad, right? So I think it's very important when they come in, you kind of like service them and keep them happy. Okay, so how are we going to build and explain a churn model, right? Even to marketing to send offers. So the first thing to do, right, as a data scientist or a business analyst. This webinar is for both. Anyone can build an AI ML model with HTML products. So the first thing is to actually find the data, right? So data, right? You want to find a historical data of customers, so both churned and have not churned, right? It's extremely important. So if you just bring the data where customers have churned, that doesn't tell anything. You really need something to compare with, and so you need to have both. So let's say you have customers in the last 2 years who stayed with you and are also left halfway, then you really want to bring all the data. And ideally, you want to have a tabular data set. I'll show you some data that I have. You might actually relate to it. So you really want to know when they joined, could be a date or could be a tenure value, how much they paid every month or like total amount they spent with you, the different service tiers they're in, different payment methods they have. For example, some people may have one credit card, two credit cards. Sometimes they may have PayPal. Sometimes you want to have that. And then you want to bring in the demographic data, which city they're in, whatever data you had collected and they give you permission to share with you, right? So you basically have the data. And I think it's important to actually collect the behavioral service use variables. When I say behavioral variables, like how many times they use the service, or if you're in a cell phone situation, you probably want to know how many minutes they talked, right, every month or overall, right, or the average minutes per month. So you can bring up any type of data. So ideally, you would have one row per customer, and you have some aggregated data across those columns. And that's pretty easy to do, right? You don't have to overthink it. Just have something that's representative of a particular thing that you're concerned about. The one thing about AML model is it can only build a model with the data you give, right? So it can't really like think outside the box in terms of no AI today can think outside the box and go fetch the data outside, right? Unless you augment the data, we can of course augment the data automatically, but you still have to sort of bring the data in some way and give it to the tool, right? And with driverless AI, we also support NLP text. So if you have some customer reviews that they provided some feedback or some complaints, you probably want to aggregate the data, just put them all in one big text column and then bring it so we can run some NLP models that will become part of the big. So basically, we'll be looking at categorical values, numeric values, text data, any keywords that are actually predictive churn, like things like I'm frustrated and I'm upset or things like that. So our algorithms will be able to catch it, our transformations will be able to catch it, and then make it part of the model. So the first thing is data. We talked about that. The second thing we want to do is to actually split the data into training and test. Okay, so both are historical, right? So you have the data So you split into training where we're going to build the AI ML churn model, right? The algorithms are going to go and figure out what columns and what features are actually driving, are creating churn, right? It's the predictive of churn. And then we're going to predict on test, right? The test data set, which is basically a holdout data set. The holdout data set already has the value, whether it's churn or not, except that we're just trying to pretend like the value is not there and trying to predict, and we're going to compare the actual versus predicted and see how well we found the problem, right? That is something that you need to test. And then, obviously, you want to have a list of customers that you want to score on. Again, you want to score on everything, all of training and test if you really wanted to. But if you have a separate list of customers, maybe like who joined this year, and you want to score on it, you can actually score on that set, and then you can actually rank order the sort of like the score, and then we're also you can also interpret, for every single row of prediction exactly what happened. So I'm going to show all of that in a demo, right? So I'm just going to give you the steps, and I'm sure we're going to share the slide with you later on. But the key thing is find historical data, split the data into training and holdout, build a churn model on the training data set, try to predict on the test data set, and then we're going to interpret the model, and then we're going to hand off the predictions to marketing, right, the rank ordered list along with all the reasons on why someone would churn. And that's sort of what the demo is all about today, okay? So it's probably easier to see it in the demo than me talking about it. All right, so let's go to a demo. Let me share one of my screens, and then we'll look at the data first, and then we'll go into the tool next. Bear with me for a minute here. All right, go back here, screen share. Coming up. There we go. I hope you can see my screen.
Yes, we can.
Thank you, Patrick. Yeah, there we go. So I'm sharing a spreadsheet with you. This is kind of cool. Like we're not in the tool yet. So the data looks something like this, right? In your business, you can actually think about finding this sort of data, right? So you have a customer ID, which is obviously anonymized, right? This is from a Kaggle data set, right? So I just pulled this as an example. And you have a column is churned, right? This is known as a target column. So you'll see like two values, 0 or 1. 0 means they're still a customer with you, and 1 means they're gone, right? They churned already. And then you have some other variables. In this data set, the city is actually a code because anonymized. It's probably like, San Jose or Los Angeles or, name a city, right? And then you have the age of the customer. Now, this age is not tenure exactly. This is the actual age that they shared with you. As you may notice here, there are some undeclared ones, and that's perfectly fine with the tool that we're going to use. You don't have to overthink it, right? If it's useful, it's useful. If not, we'll drop it, right? Or we'll try to include it. And then you have a gender, right? And then there's a registration method. Apparently, there's not a whole lot of information on that. In your case, this could also be a referral, right? Where the customer came from, like you had a marketing campaign. It could be like which campaign that brought them here. So think of everything that you can possibly have about the customer, right? They probably came through a webinar, or they probably came through a conference, or how they became a customer, like the touch point, right? And then when did they register? Now, this could be a date, or this could be, if you have a snapshot of this, churn data set this month, this could be like a tenure as well. Could be a number. The plan list price that they signed up for, I wouldn't pay too much attention. Just think of it like some numeric values, some dates, right? And then the average amount paid. Maybe they got a discount or whatever. So just think of like things that you offered them, and then you kind of include that in the data. And every business, it's different, right? Sometimes you may have more columns, sometimes you may have less columns. And this is a field, this is probably my favorite column, so auto renew flag, right? So basically the customer subscribe for auto pay, right? So which means like every month, as a business is charging the credit card, right? Or If it's no, then it's in the email notice, they log in, and then they pay every time, right? So this is a very important feature, as you'll find out in the demo. How many times they underpaid, the late payments sort of thing, how many transactions they did, number of payment methods, like how many different payment methods they have, like multiple credit cards and things like that, and what's the default payment method, right? So, I mean, that's in this data, and you don't have to have the exact same thing, but you kind of get the idea. Like, it's a real nice mix of dates, some categorical values, some numeric values, some continuous values, right? And this is kind of like what the data set we're going to use. And so let me quickly jump to the tool. And, there's also a test data set. Let me show you the test data set in a second. Screen share. How do I, stop sharing. Okay. So the test data set looks exactly like this. This is the training data set that we're going to train the model on. And the test data set, I'm still new to Bright Talk. I should be able to get that. Yeah, bear with me a minute. So the test data set looks exactly like the training data set. There's no different, except that it's got different customer IDs. So remember, we have the training data set and the test data set. I'm probably sharing the same training. Yeah, the test data set is over here. Yeah, so the test data set looks exactly like the one that I showed you, except that it has different customers with the same information, including the churn column, whether they're churned or not. Because that's the one that we're going to test the model and see how close we are to the actual versus predicted. Okay, so let's go to the tool here. And then we will load both the data sets in the tool and then start building the model. Chrome tab. There we go. Okay. So I have both the data sets here. Obviously, I have more data sets that I'm playing with, but here is the trained data set. And you can see, like, we have all our columns, right, that I showed you in the spreadsheet. It's already loaded to go. And then the test data set is exact similar data set, except that it's got different customers. So we're going to build a model on training, and we're going to try to predict on test and compare the results, right? And then see. And the model is really good. It would actually come close to the actual truth. That's how you know you can completely go off and score on another data set and be confident that it works. So what we really want to do is the key thing about machine learning is that you don't want to overlearn from the training data set and memorize everything. So you really wanted to generalize, right? So as opposed to memorize. If you memorize, you're going to be overfitting. So when it's looking at data it has not seen before, it's going to go crazy. So you really want it to be generalized. So when you actually predict on data set that is not seen, it'll be very close to the answer. And that's what we want. So how do you build a model? So let's go ahead and do a predict. So what you're seeing here is a driverless AI from H2O. It's an automated machine learning tool. Where with a few clicks, you can actually build an AI ML model that you can actually go to production with, right? So I picked a training data set. Now I'm going to pick the target column. This is a column that had 1 or 0, right? And then pretty much, so it's actually looking at the data and then coming up with a plan on how to build a model. If you're a data scientist, you'll probably recognize the decision tree and light GBM and XGBoost GBM. So, and what you're seeing here is a recipe to build a model. So you have multiple algorithms that it's going to try on. It's going to do what is known as cross-validation, threefold cross-validation, which is basically taking this 30,000 rows in the training data set and split them into training and validation, and then trying to play games with itself, right? So it's going to take the 2/3 of the set, try to predict the 1/3, and then switch around and until the model is optimized. So it's going to run multiple algorithms. It's going to do cross-validation. And most importantly, the most interesting feature here is it's going to do a lot of feature engineering, right? Automatic feature engineering. So it's going to take the categorical values, convert them into numeric values, and then it's going to take numeric values and try to bin it, and it's going to add and subtract columns and trying to see if there's anything that's interesting when you combine multiple columns. It found a date, so it'll go and check to see if it's a holiday, the register on the holiday. It found some text data. I need to see where the text came from. So it's going to actually basically look at some of the categorical values. It'll see if there's a valid, it has to be treated as a text column or not. So it's going to do one-hot encoding, all of that on its own. right? You're not going to write any code. You just said churn column. So, so there are three knobs here: accuracy, time, and interpretability. So the accuracy knob, basically, when you dial it up, it is going to do more cross-validation, a more rigorous, model building. Obviously, it's a trade-off. It's going to take more time, and time is a separate axis on its own. So when you dial this up, then it is going to do more feature engineering and try more things, and then the interpretability knob basically allows you to control the complexity of feature engineering, right? The lower the value, the more feature engineering it will do. The higher the value, it will do as very simple feature engineering. So there's like so many things you can do with these three knobs. I'm not going to cover all of that in today's webinar. You can go to our website and register for training, and you can play with the product on your own. And then we're going to pick a scorer, right? So because it's a classification problem, true or false, it's a binary classification. You can see like the 30,000 rows, 1,940 people churned. It's minority class, and there are two values, unique values here. And we're going to use area under the curve. It's a very popular evaluation metric for the experiment. And higher this value, the better the model is, right? The more accurate the model is. So let's just leave that for now, and then we can go ahead and launch this experiment. Right now, what driverless AI is doing is actually going and looking at the data, looking at what is categorical, what's numeric. It's going to play with this, right? And then it's looking at daytime columns. It's started splitting the data to 30,000 rows into multiple splits, and then it is going to do tuning, model tuning, and you'll start seeing some initial results on the screen, right? So just give it a couple of minutes for it to run. It's also checked for data leakage, right? So what is data leakage? Data leakage is something where you have columns that give away the answer right away. And those columns may not be available to you when you're scoring, so it's very important that it actually catches those things. So we're testing for all of that, and without you writing a single line of code, right? So now it's actually once it looks at the data, it has a broader plan, and it's going to start tuning, right? And then we start getting some notifications. So it says that the data has been balanced, right? So the 30,000 rows, you have 1,940 is the minority class. It's telling you that there are things that you can do, and it's saying that it's going to drop the customer ID column, which is of no value here, right? The customer ID column is a very unique value, and there's no point memorizing that in the model. So it's actually dropping the column. So it's doing a bunch of cool stuff, and it's already built 3 models, and my settings are really low here, so it's going to finish really quickly. So I wanted to focus on these, right? It's already doing some transformations like target encoding. It's saying that I took the common payment method for the last model, came out to be a very important feature. The auto renew flag that we talked about, the auto payment flag came out on top. The number of transactions a customer did is also predictive of churn. And the fourth one is extremely interesting. It actually combined multiple columns like auto renew flag city and common payment method, and combined multiple columns and created a composite column, and saying that when you combine these 3 columns, it's predictive of churn, right? Go figure. We're going to find out more about this, right? And then there's a lot more transformation that happens, and all of this is happening under the covers. Let's see. Let's do a time check. Okay, so this is going to finish in a few minutes, so let me go ahead and show you a finished experiment while this is running. This is how a finished experiment looks like. So for the last model, you can see like it built a bunch of models, and then it came up with some really interesting score of 0.84, which is like pretty high in a very shortest amount of time. I think this one took maybe like a couple of minutes. We could have just waited on the other one. It could have finished by now. So, and for the very last model that it built, from the 14 columns, right, the original 14 columns, the final model is a light GBM model with 37 features, right? So how did it go to 37? Because we took the 14 columns, we did feature engineering, and then out of all the feature engineering it did, it picked the 37 of the best of original and derived features and came up with the model, okay? So the model is good to go, right? So now we can do a couple of things, right? As we mentioned in the slides before, the next thing we can do is to actually score on a test data set, right? So let me go ahead and score on the test data set. Take the model. Remember we said we're going to build a model on training, and we are going to score it on a test data set. And we'll keep all these columns, original columns, so that it doesn't look cryptic, and we can look at what the model predictions are and compare with the original column churn, right? So we're going to say done, and it's actually making predictions. And what is happening right now is that all the feature transform unit data and the model tuning data is part of the scoring pipeline, right, that the driverless AI created. It took the scoring pipeline, and now it's scoring on the test data set, and the predictions are ready to go. So let's go ahead and look at the predictions, how it looked, and kind of look at that, okay? So let me stop this for a second, sharing, and then I'll share the can you see my, Patrick, can you see my test screen?
Yes, I can.
Where it says churn test, okay. And then, oh, I think I shared the wrong one. Let me share it again. Sorry about that. Take a minute here. I'm trying to share the right window. There we go. Perfect. Okay, so yeah, so this is how it looks like, right? So I just highlighted this. This is the original column churn, and if you move to the right, these are the two columns that your predictions created. So you have a churn.1 and you have a churn.0. They both add up to 1. The higher this column, right? So let me just zoom in a little bit. So this is like the test data set, and these are the two columns that were generated by the model. And so let's just sort this by, so you have the is churn.1, and that gives you the churn probability, and this is the sort of like the complement of that. This is 1 minus this value is this. So I want to actually sort this. So let's do a sort from largest to smallest. And then, so this is a rank ordered list of the customers that the driverless AI thinks that the customers will churn, right? So, and then let's go to the left side. Yeah, you can see like the original values are all 1, so there is a false positive, right? So this customer did not churn, even though driverless AI, the model was given a higher score. And that could be a potential churner, right, that we didn't catch before. But so you can see like all the 1s are there, the original values. If you go down the list, you'll see more and more zeros, right? More and more zeros and less 1s. And that's kind of how the scoring works. So if you look at the top, if I had to take the top 50 of these, like the higher score, and those are the potential churners, right? And that's exactly how you will use the model. So one thing we have not talked about is how do you know, right? Like, okay, so you're saying in churning and why, right? So that's the question we're going to answer next. Is it because it's a gender? Is it because of auto renew flag, or is it the average amount paid? Why do you think the customer is going to churn? And that is part of the next part of the demo, right? So that's the explainability part. So I'm going to share that with you in a moment. Let me go back to the screen here. Yeah. I got a little snafu here. Let me see. I'm doing a screen share, one computer, one screen next. Yeah, there's some issue with sharing my screen. There we go. Okay, sorry about that. Let's go to the Chrome tab. All right. So how do you do that, right? So this is a finished experiment. So we're looking at this. I have probably a slow internet, I think.
Hey, Karthik, we're currently seeing the demo slide, just so you know.
Yeah, okay. Patrick, I'm having a little slow internet here.
Okay. Well, in the meantime, folks, while Karthik is figuring this out, if you want to start asking your questions, we'll collect them in the questions tab. We should be getting into Q&A in the next 5-10 minutes or so. So it's probably a good time to do that.
Yeah, I think I may have the, yeah, there we go. Okay. I apologize, folks. I have a little slow internet here, but yeah, we should be on our way here. So we're talking about, okay, so let me make sure that I'm sharing the right screen.
Yeah, we see the test spreadsheet.
Okay, got test spreads, Shapley. Yeah, there we go. Okay, so one of the things that I will probably go back to the tool and show it is Driverless AI can not only generate the predictions, but also the contribution of the individual columns that actually cause us to mark us as churn, right? So this is a test data set, and we talked about these two columns that we generated. In addition to that, the tool can also generate the contributions of each of the column that's actually causing creating that high score. In this case, you see that for this customer, our model explainability is showing that the auto-renew flag is like one of the main reasons why this customer would churn, okay, followed by the common payment method, followed by the number of transactions. So now you're getting a reason on why this customer was scored of such a high churn score of 0.81. So let's go ahead and look at the auto-renew flag, right? So the auto-renew flag is set to no, right? And that's interesting, right? Because the credit card is not charging automatically, so they have a high propensity to churn. However, if you look at where a customer had an auto-renew flag of yes, and still had a high score, the number one feature was not the auto-renew flag. It was the number of payment methods. This customer have way too many number of payment methods, and they have underpaid a lot. So, and that actually tells you that they're churning. So for everybody, it's a little bit different why they would be marked churn, and that's exactly what this machine learning interpretability does, right? So, and then it also creates a reason codes. Now, the marketing can actually, when knowing that they could potentially churn, now they can actually reach out to these customers and try to, incentivize them, saying that if you go to auto pay, then we would actually give you like the first next month free, exempt them from paying subscription and get them to auto renew. Similarly, there's nothing you can do about somebody underpaying, but so, and if you just go down the list, there are probably multiple reasons why it would. In this case, it looks pretty obvious that the auto renew flag and the number of transactions in this case, when you look at the number of transactions, they're all number one, which means it's it's kind of like this customer just had a very recent customer, right? So, and there could be sometimes infant mortality with customers, right? They come in, the longer they are, the more unlikely to churn. So this could be one of those cases. So now that you have the reasons, now you can wrap your head around like what you can do to keep this customer with you, right? So hopefully I'll have a chance to show you another one of the other features in the tool. Meantime, Patrick, if there's any questions, I'm happy to take that while I'm actually
Sure. Let's go ahead and let's get into the questions here. We have some great ones in the chat window. We'll try to get to all of them with time permitting here. First question is, how do you compute the churn probability? Which modeling are you taking into account?
Yeah, that's a great question. So if you look at the experiment, right, that I was showing you, the final experiment is actually a combination of, it's a light GBM model, right? So the light GBM model with the 37 features, right? So starting from the 14 features, we created all these composite features, and we actually discovered how to combine multiple columns to create the final model. So the algorithms, the way it works is you will not get a 0 or 1. Instead, you will get a probability, right? So it can't really say churn or no churn. But, however, there are thresholds that you have to choose, which I haven't shown you in this webinar, after which you can say that if the number is higher than 0.75, then you're going to have extremely less false positives, and you can be sure that this customer is going to churn. But it's really the algorithm light GBM that's actually creating that churn probability. And when it's creating the probability, it's actually looking at the way the probability is calculated is looking at the discriminative value of the churned rows versus the non-churned rows, and comes up with some sort of an internal ratio just beyond the scope of the webinar to come up with those numbers.
Great. Next question here is the ID column picked up automatically while specifying which features to use?
Say it again, Patrick. I don't think I understood the first part of that.
Is the ID column picked automatically while specifying which features to use?
Yes. The ID columns are detected automatically because they are so highly unique. And also the fact they have an ID in the name, it will be checked twice to make sure that, and then they will be automatically dropped from even before going and building the model.
All right, this one is a little bit more involved. It seems to be a two-parter. So in an actual setting, this prediction is for a specific time frame based on some specific range of historical data. So what is the one time frame at which this model is running? And two, for what time frames is it predicting the churn? How is this all managed or automated in H2O driverless AI?
Yeah, that's a great question. So this goes back to my original slide where it's extremely important how you split the data set and what exactly you're predicting. I think you need to understand that first, right? So for example, there's one way to do is to look at, a few years before, and then you're trying to predict the last few months, right? That may or may not be correct. But so the way that I've seen how churn models are built is you actually pick cohorts, right? So you basically pick a cohort, so you can build multiple models, for instance. So you can say, okay, let's look at all the customers who joined 1 year ago, right? Just like on January last year. And then look at how many of them churned and how many of them did not churn, and then build a model. So you can build quarterly cohorts, like for the first quarter of 2 years ago, second quarter of 2 years ago. That way you're treating those customers in the same pool as opposed to comparing a customer who joined like 2 years ago versus 1 month ago. Right? It's extremely important that you pick those data sets and build those models correctly. And the only way you can validate them is during this overfitting, right? So if let's say you have a holdout set that's recent and then your training set is historical, and you did really well on a historical data set, when you're trying to predict a test set, and if it's not accurate, then there's a pretty good reason why you would go with a cohort model. But if your training data set is as good as a test data set, then there is proof that it still holds good, right? So you really have to play with the training and the holdout set to make sure that it's not overfitting, and that is your proof that you are actually splitting the data set correctly. And I hope that answered the question.
All right. Next question Is the probability well calibrated? And in the feature engineering step, does H2O do feature crosses?
Feature, did you say crosses, Patrick?
Yes, feature crosses.
Yeah, so that's a really good question. Yeah, it does those underneath the covers as part of the automatic feature engineering.
All right. Did the automated system also do oversampling / SMOTE, SMOTE?
Yeah, really good question. In this case, the data is imbalanced, as you can see. So basically, we have a threshold for after which automatic oversampling kicks in. But however, if you're eager to do it even with a slightly imbalanced data set, then you can actually go to the expert settings and you can actually turn it on, right? So we do have that. Not only that, we also have imbalanced models like LightGBM and XGBoost models built in, so you can also turn that on and see if that helps the score.
All right. Let's see. What is done with missing values like age and gender?
Yeah, great question. So if there is a lot of missing values, then what we do is that we actually drop the column. But if there is a small fraction of missing values that are there, then we actually, for the categorical value, then we actually try to combine those missing values into a single categorical column, like an empty categorical column, and then actually use that as a separate category. For numeric values, we do some imputation. I think it's a mean value imputation. We also allow you to bring in your own imputation strategies as part of recipes. So you can actually engineer the data that you want. So there are multiple options there. And what I've not shown you is a way to visualize all of this to decide how to approach this.
All right. What kind of variables do you think are the best ones to describe churn rate in a bank?
So the different ways. I've been working on this problem, and there are so many ways to define the churn rate, and it really depends on. And there's more than one way to explain it. The simplest one that I gave you is just for the simplicity of the webinar, just to keep it simple. It's just kind of like a street definition, right? So you take the number of customers at the beginning of the quarter, and you look at the end of the quarter. You subtract them, and then you divide that by the original number of customers you started with. And there are different definitions of churn on the internet. If you look at it, they would actually, some of them will remove the new customers that were created during that quarter. And there's like so many different ways that you can define. I would go with the definition, the simplest definition to start with. And obviously, if you wanted to a little bit more nuanced to satisfy your business, obviously you can use the other variations of that.
All right. Can we see the metrics of the prediction, i.e. accuracy, precision, recall rates?
Yes, we can. Let me see if I can do that real quick. So we have a diagnose model feature. So you can basically run the model diagnostics. I actually created one already. And so any new data set, you can get all of this. So this is the diagnostic for the test data set. So you can see the area under the curve is 0.84. You can look at the confusion matrix and all of that, the lift chart, gain chart.
Great. What is the list of all methods doing auto feature engineering?
So some of that is documented on our website. If you go to docs.h2o.ai, you can actually go and look at all the different feature engineering that's available. We have like 30 to 40 transformers by default enabled. And beyond that, we have a GitHub repository where we have hundreds and hundreds of features across outlier detection and numeric values and winsorizers and things like that. You can actually import them into driverless. So the list is endless, and you can write your own. The most important thing is you can absolutely write your own feature engineering and bring it into driverless, and it'll compete with the native ones and become part of the scoring pipeline.
All right. Is the contribution computed based on Shapley values?
Yes.
Great. How would you use the same data in a case where there is no is churn column given, so like an unsupervised scenario?
Yeah, so driverless AI is a supervised learning tool, and there's a H2 open source version that's available. It doesn't have a whole lot of feature engineering or NLP features, but it's a very popular tool that is being used by enterprises. I showed you in the original slide the 20,000 customers using open source H2O, and that one supports all kinds of flavors of unsupervised clustering, k-means, so you can actually do isolation, forest, so you can do like so many things with that. Yeah, so that's how I would do it. However, the way unsupervised learning is used inside driverless is actually to create features like cluster IDs, automatic generation of cluster IDs that goes into becomes part of the feature engineering. But for using this tool that I just showed you, you need to have the labeled data set.
All right. If marketing takes action based on the reason provided and churn is successfully prevented, doesn't that reduce the accuracy of the model? And how should I deal with this situation as a data scientist?
Yeah, that's an absolute wonderful question. Yeah, you don't want it to become like that's absolutely important. So whenever mitigation actions are taken, I think it should be become part of the features that you need to add. Let's say marketing sensor. Typically, you'll see like a typical data set. You'll see like the number of campaigns that are being sent to the customer. When you do a prescriptive action, you need to make sure that that's added as part of your database, right? As part of the customer, the date that's contacted, or the any mitigation values that you did, and that can become part of the model. So you have to retrain the model every month, and when you do that, we can be sure that those features are actually taken into account.
Great. This is a pretty involved question. Seems to be a three-parter. Number one, are the variable importance predicted using Shapley values? Number two, is the splitting done chronologically? And number three, what if you are interested in a time frame for churn? Let's say you are interested in churn within a year. You would need to split chronologically and have a 1-year gap to account for customers existing in both training and testing. Can this tool be used in this kind of situation? Sorry, that was kind of a lot. Let me know if you need me to repeat anything, Karthik.
No, I see the question here as well, Patrick. So yeah, so the number one, on the variable importance predicted, the answer is no. So when I showed you the original variable importance on the screen, those are just coming from the algorithms that are being run. If it's like GBM and XGBoost, then you're going to get the variable importance from there. But when you go to the machine learning explainability tool, which I didn't have a chance to show you, then we take the black box models, we look at the actual predictions, like the churn predictions, and then use that as a target column, as opposed to 0 or 1. We use the prediction probabilities, and then we compute the Shapley values. So it's, and then based on that. And so the splitting is not done chronologically. It's up to you to how to split. You can do chronologically if you really wanted to, or if you want to do a stratified split, it's really up to you. I just split it randomly just for the demo, but you can do whatever you want. We have a splitting feature as well in the tool. Yeah, so what if, the third question is, what if you're interested in a time frame for churn? Let's say you're interested in churn within a year. You will need to split chronologically and have a 1-year gap. Yeah, you can do whatever you want with the tool. So we do have some basic default split features built in, but if you really want to split in a particular way and you write your own Python recipe, you can actually upload it into driverless AI and have it run and split within the tool. Something again that I haven't shown you, but it's part of a documentation. When you buy the tool, there is a way to upload your own Python recipe to access the data that's uploaded into driverless, and you can split any which way that you want.
Great. All right. Next question is, would you think about deploying deep learning for churn?
Sorry, Patrick, can you say it again?
Yeah. Would you think about deploying deep learning for churn?
Yeah, that's a good question. So the deep learning is also part of the driverless. We haven't enabled it by default. We don't use deep learning for tabular data sets with numeric and categorical values because we know it underperforms and takes a lot of time. But if you had NLP or images, then deep learning would automatically kick in. But if you really want to use TensorFlow neural models, then you can go to expert settings and force it to use deep learning and see what the results are. And typically we have seen XGBoost like GBM doing way better than deep learning, even though XGBoost runs on GPU in driverless.
All right. Can you share some insights on what kind of explainability techniques are utilized here?
Yeah, absolutely. So I think I'm sharing my screen here. So one of the things that I really want to show before we had the internet issues is our MLI tool, where we show things like Shapley from original columns. We also show transform Shapley with the transform columns. We also support K-Lime, for instance. We also support K-Lime, which is basically a Lime model done after doing k-means clustering. We also support random forest. For example, we do surrogate models, decision tree surrogate model, random forest ones, and then we do things like partial dependent plots. What I've not shown you again is sensitivity analysis, where you can do what if analysis by changing. For instance, if you're thinking a customer is going to churn, you can actually play with the price and see if the probability changes for churn. Like what will be the sweet spot for the customer to lower the churn probability. So you can do that with your sensitivity analysis tool. I hope we had more time to show it, but unfortunately, you can actually go and play with this and rescore the model by changing values. And then we also have the disparate impact analysis, which is basically checking the bias in the model, right, to see if there's any disparate impact on a protected variable like gender or ethnicity. So typically you can build a model without including those columns, but after you build a model, you can come here and include them and see if the model captured any indirect bias or anything like that. So the MLI feature is pretty rich in driverless, and there is something for everybody depending on what you're comfortable with. Shapley being the most popular one, and there are reasons why somebody would go K-Lime, that sort of thing. So, and then you can obviously download all these values, the transform values, the reason codes. The thing about machine learning interpretability in driverless is you can actually build a model outside driverless and bring the predictions and have it interpreted for you. So there's a lot more than that. It's a standalone feature in the product. So.
All right. I think that does it for all the time that we have for questions. I want to thank you, Karthik, for taking the time today and doing a great presentation. I'd like to say thank you to everyone who joined us on the webinar as well. The presentation slides and recording will be made available on our Bright Talk channel, and we hope you have a great rest of your day.
Thank you all.